Today we're going to learn about distribution approximation. You have learned this in your high school days. It's about changing from binomial into normal. Okay? And nothing special about that. The thing is, this one is discrete and this one is continuous. So there's a slight small problem where you need to do a continuity correction. Do you remember about continuity correction? About plus minus 0.5. Okay, you have learned this in your school days. Can we always do this? Where there are the three rules that you need to follow. Firstly, the n must be more than 50. Secondly, the p must be between 0.1 until 0.9. Thirdly, NP, your mean, must be more than 5. Once you satisfy these three rules, then only you can do this technique. When do we want to do this? When do you want to use normal approximation? You do it when n increase a lot. Like if you start the question with n equals to 10 and suddenly it increases n equals to 100 or 200, that means it's a big signal for you that, oh, I need to use approximation technique. Or secondly, when the question asks you to question say, hey, use approximation technique, then you need to use approximation. But sometimes when the question asks you to do it, it kind of violates these rules. It kind of breaks the rules. At that moment, if you are in an exam, if you see such a question, you don't argue much, you just use normal approximation. Don't try to argue, hey, will this work, why won't it work, and then you miss your marks. Alright? I'm going to show you one example, which will come back to this example later. Let's say you are given something like this. Let's say you start with an x binomial where you're given is 200 and 0.3. What can you say about the 200 and 0.3? 200 is and 0.3 is the p. So when you try to find the normal, what's the mean to be? Mean is NP, 200 times 0.3, 60. What about the variance? I'm going to find the variance. It's NPQ. The Q is 0.7, 1 minus 0.3. You get yourself 42. Okay? Now let me ask you questions. Can this, why can I do this one as a normal? From binomial, why can I use approximation? That might come up in exam. The question asks you, why can you use normal approximation? Then your answer must be depends on these three rules. You need to memorize this, right? Sometimes it can come out in exam so you can miss 3 marks easily. Okay, so firstly you answer that. Firstly, my n right now is 200, which is more than 50. So secondly, you can answer as well. My p is equals to 0.3, and my p right now is between 0.1 and 0.9. Okay? And finally, say your NP is equals to 60, which is more than 5. Alright, you need to show this for you to gain those 3 marks. If they ask you why can you use normal approximation, understand? So it depends on who memorize it or not. Okay, yeah. Okay, I would like to teach you about continuity correction. There are many ways how to solve this one. I'm just proposing one of these. Can I have your operation? If you don't understand, ask me straight away. Okay? If you don't understand, ask me straight away. I believe this will make the works a lot easier. Let's say if I ask you for Px less than equals to 4. Okay, so we need to do the plus minus 0.5. Firstly, you draw the number line and you put down 4. Which way am I heading? Left or right? Left. Okay with that?
Yeah.
Now, this one is equal. I'm going in this way. I need to include the 4 as well. You okay with that? I need to include the 4. So I'm drawing a bracket in this direction. Why am I going in this direction? Because I want to take the 4 include in my arrow. You okay? Why am I going in this direction? I want to include the 4 in my arrow. Why do I want to include my 4? Because that's equal over here. Okay, if I'm going in this right side, I plus 0.5. Okay, so my x right now, after continuity correction, I'll get myself 4.5. Are you okay? Now what about this? Px, if I want to do it for it to be less than 4. I not do the same technique. Before, which direction am I heading? Left way. Should I include the 4 or should I not include the 4? Why not? I'm not including the 4, so I'm going in this way. Because I'm not taking 4 with me. I'm going this way. If I do on the left, I minus 0.5. Until there, are you okay? Do you want me to repeat them again? Please raise your hand, I don't mind. So I get myself Px less than 3.5. Okay, good. Alright, there's one slight question. Sir, should I still put include equal over here, sir? There are many ways to look at it. Because this is still in the case of discrete. This after continuity correction, it becomes a continuous. So when it comes to continuous, it doesn't really matter whether that's equal or there's no equal. And then it comes from which disciplines or which perspective you are from. Some teachers, including me, our perspective that hey, that's equal here, so let's just keep the equals there, which is correct. Some teachers say it's already in continuous. Continuous, you don't care whether that's equal or not, so you don't have to put it. That's also okay. It depends on which perspective you want to follow. Right, so now let's try other examples. What about if I give you Px more or equals to 4? Another one is Px more than 4. Give you 1 minute for you to try. Pause the video. Okay, have you figured it out? So now let's say if this is 4, I'm going more is in the right direction. I want to include the 4. I go left or right? I go to the left or go to the right? I want to include the 4, right? So the bracket. The left bracket or right bracket? So I minus 0.5. So I get myself Px more or equals to 3.5. What about this one? right direction. Do I want to include the 4? I want. So my bracket to the left or my bracket to the right? The right, so I have plus 0.5. So Px more than 4.5. I highly recommend you use this technique. Even I myself, if I don't use this, I might get things wrong. So this kind of like safe bracket for you. Okay, trivia. What about this? And here people are thinking. Share, how? How? Straight line. Two bracket. You let them out. The correct answer is you make a star. Okay, just kidding. You plus 0.5, you minus 0.5. So P x is between 3.5 and 4.5. Should you put equal? Yeah, up to you. I don't mind. You guys okay? Awesome. Okay, for this one here, without me helping you, can you do the approximation? The continuity correction, the plus minus. Now we compare our answers. Okay, 1 minute from now. Pause it. Okay, so let's start. So what about this one? What do you think? So we go heading in this direction. Do you want to include the 4? So we got ourselves Px 3.5 and 8.5. You guys okay? So this one here, I don't want to include the 4, I don't want to include the 8. So Px 4.5, 7.5. Am I too fast? Do you want me to explain it? Anybody want me to explain? Please raise your hand. And finally over here. Oops, this is wrong. 3.5, 7.5, and we are done. Are you okay? Okay, so let's try. Going back to our question just now that we have set the early part, where it's binomial, then we change to normal approximation. Now you want to find yourself for x less than 50. What should you do firstly? We have find our normal over here, approximation. Before you even begin, you need to do continuity correction for this one here. So if I say this is 50, going this direction, I want to include the 50. So my new x is Px less or equals to 50.5. Once I find this one, I now find my z. So what's z? 50.5 minus mean 60 over 42? No, you can add the square root 42. Remember, this is x minus mean over standard deviation, not variance. This one here is variance, and one here is standard deviation, which is your square root. You press that into your calculator, what will you get? 1 point. Sorry, negative 1.4. .466 or 7 you can go. You can go 66. So now you try to calculate for replace x with z. Less or equals to negative 1.466. Where is it on the bell curve graph? On the left side because it's negative. So I'm heading in which direction? Left or right? Left. Left. What should you do from here? Flip it. Because it's a negative area, so you flip it. So now you look inside your statistic book. Normal distribution table. 1.466, you can't really find it here, so you take 1.47. So 1.47, 0.0708. Okay, so that will be the basics for this topic. Hopefully you guys got it. Alright, thank you for listening. Please comment, share, like, and subscribe. Thank you.